Hi there, everyone. Good morning or good afternoon, depending on where you are in the world, and welcome to this webinar on ETL versus ELT. What's the big difference? So this webinar is hosted by Matillion. My name is James Johnson, and joining me is one of our senior solution architects here at Matillion, Kalyan Arangam. So the way this session is going to work today, I'll provide you a short introduction to Matillion and how we can help Amazon Redshift users to build their data warehouses in the cloud. Following this, I'm going to pass over to Kalyan, who will deliver the main part of the webinar, demonstrating the main difference of the ELT versus ETL approach, 3 major ELT techniques, and the best ways to implement them to benefit your data warehousing strategy. So following that, there'll be plenty of opportunity for Q&A, and of course for you to speak with Kalyan about any particular use cases you have. So without further ado, let's get started. So if you haven't heard of Matillion before, Matillion markets themselves a data integration tool specifically designed and purpose-built for Amazon Redshift data warehouse. So this tool is quite unique in its approach. What we do is we follow an ELT approach, and what Matillion does is gets your source data directly into Redshift, allowing you to transform and actually prepare your data for analytics by using the power of Redshift itself. So essentially what you're doing the ETL inside of Amazon Redshift. So what this actually results in is Matillion having a really small footprint compared to with other ETL tools out on the market. And you also get the benefit of working on it and seeing your raw data directly from within the tool, which has its own inherent benefits. So Matillion ETL itself for Redshift launched on the AWS marketplace in 2015, and we've grown a really large global client base, which ranges from small startup companies to large enterprises, which span virtually every vertical. And you can actually see some examples of some of our current customers on the screen at the moment as we speak. So Matillion is actually delivered as an AMI, an Amazon Machine Image, on the AWS marketplace. And you can actually launch it directly inside your EC2 console, connect automatically to your existing Redshift clusters and your S3 storage locations, and that will enable you to build out your first jobs in under 10 minutes. I just wanted to clarify what we mean when we say the ELT approach for any of you that haven't seen this before, and of course how it differs from ETL. So to do this, I'm going to enlist the help of a couple of diagrams just to illustrate the key points. The first diagram should be quite recognizable to those of you from the ETL world, as this is the traditional method of extracting data from numerous source platforms, actually loading the data into a dedicated transformation engine. And when that data is in the desired format, you load it into the data warehouse ready for your analytics and visualization. So in contrast to this, the diagram that you'll see coming onto the screen now on the right-hand side actually explains what we mean by the ELT approach. So in this, we allow you to extract and load the E&L portion, the raw data in one move straight into your target data warehouse platform, which in this case, we're obviously referring to as Amazon Redshift. So the data doesn't actually run through Matillion or any transformation engines, as in the traditional approach. It's simply loaded directly to Redshift, and then you apply all of your transformations on the data inside of your data warehouse. So obviously there's many benefits to this approach, and some of the main techniques that will provide some great results. So I think this is obviously a perfect moment to hand over the controls to Kalyan, so you can actually get started on the main part of today's session. So over to you then, Kalyan.
Hello everyone, I'm Kalyan Arangam, and I'm a solution architect with Matillion. And today in this webinar, I'll be talking about some common approaches or workflows, or patterns, if you'd like to call, in ETL, how we traditionally tend to work in ETL, and how we work the same processes in using ELT approach that we subscribe to in Matillion. One of the first things to clarify is when we read the product name, we say Matillion ETL for Redshift. And the main reason for having ETL there is purely because that's what people tend to search for when they look for tools for any platform which can help them transform data. So besides saying, yes, we have Matillion ETL for Redshift or Snowflake or Google BigQuery, we are actually ELT based products at the core. And as we go along, I'll basically demonstrate how it works under the hood as well. So to talk more about ELT versus ETL, as I mentioned, we'll talk about it in the context of three very common operations, which is calculations that you tend to perform on data, lookups or joins, where you try to merge some information from two sources or two disparate sources. And then we'll also look at aggregations, how you work with them in ETL world, how that would translate into the ELT side of things, and how it's implemented in Matillion. Now, whatever we're going to talk about, the concepts, the underlying problems, they've always been there, either to do with performance in terms of how and where you bring your data in and where exactly is the best place to run your operations. Every tool comes up with some sort of way to fix a part of an underlying problem, which may say, to say one approach is better than the other. In our case, we're basically ELT through and through, and that's what we will look at as we go along. So talking about the operations as such, the first would be general calculations, where you're performing some row-level calculations. Typically, it may tend to be expressions where you're applying some functions and stuff like that. In a traditional ETL world, these tend to take place on the ETL server itself. And most modern ETL tools are fairly quick, and you should really not see much of an issue running your calculations on a ETL server. Of course, the result can either be that you're overwriting an existing column, or you are deriving a new column and then appending that to the data set, which is then pushed into your target platform as such. Next, moving on to lookups. They're a bit more tricky than when it comes to calculations as such. Let's imagine we have facts and dimensions that you tend to work with. We may just want to map a fact value or a row from a fact table to the appropriate dimension key from another table or a source. Traditionally, you would basically go row by row, and for each value, you basically perform an API lookup or execute a function which then brings back the appropriate key from the dimension, which is then appended to the data and pushed to your target server as such. This is usually absolutely fine. I think the only constraint you would have is you would need both your facts and dimensions, or whatever sources that are basically helping you with this data, to be available at that point in time. Another challenge here could also be the amount of data you're working with. When you're performing your lookups, especially, you may all have come across these issues, or even various solutions provided by various tools, where you might start with, just find me a value from the lookup table. It goes and fetches it. If the dimension table is really huge, you may have to come up with some strategies like partial caching, full caching of the data set, and so on. So depending on the capability of your ETL server, you may be able to do or perform certain operations quicker compared to the others. Coming to aggregations, they're a bit tricky in the ETL world, especially if you want to keep your granular data as well as aggregated data as such. Typically, you may want to multiplex your stream of incoming data, store this in separate different tables with different granularity, and it is possible, but again, it's usually quite complicated if you're dealing with really large data sets, and this is where sometimes some of the tools let you perform some push down where possible, but there's a lot of handholding that you need to do sometime. Now, coming to the ELT side of things with Matillion, regardless of the database, we will be performing the same operations, but in a slightly different order. With ELT, our primary focus is to load data into the database first, and we then use the capabilities of the target platform to help transform the data. Each of these platforms supports standard SQL, as well as some platform-specific features to help load data and then transform it as necessary. When I say target, here in this example, I'll be using Redshift from Amazon, and you could choose any of the other platforms that we support, like Snowflake or Google BigQuery, and the same principles would apply as the ones being discussed now. So regardless of the platform you choose, SQL is still the primary language or tool that we'll be using to work with our data as such. Coming to our operations that we were talking about earlier, for calculations, we will basically bring all the raw data into the database first, and then add a calculated column to an existing column, or something like a derived column, which just sits in addition to the data that you already have. In this case, as I said earlier, we will be using SQL to help you add this additional calculated column to the existing data set as such. Coming to lookups, let's say again, as we spoke about the ETL case, we just want to marry a fact table record with the appropriate dimension key from a dimension table. Again, this is implemented using SQL, and we'll be using joins in order to bring the data across, specifically left outer join to ensure that we do not miss out on any of the incoming data as such. One of the differences here, where we are performing our operations on the target database platform, is that the looping and lookup on your fact data and your dimensions is basically performed by your database, which has been designed and optimized for exactly this kind of thing. We no longer have the problem that the two sources are required to be available at exactly the same time. I think this is something we just discussed for the ETL approach. In ELT, because we are bringing in data, all required data, into your target platform, by the time you try and perform your join, your data is already there, and you can perform your join as and when you're able to do that. And finally, coming to aggregations, that's something that databases, especially MPP databases, are really good at. You have a whole load of hardware at your disposal to do an aggregation very quickly. And irrespective of the database you choose, it could be Amazon Redshift, Snowflake, or Google BigQuery, all are MPP platforms and have been designed and optimized for handling large volumes of data and basically perform these operations real quick. This basically shows the data architecture which underpins ELT. I have two fairly similar slides like these, and they're both commonly used approaches. This is the basic ELT pattern where the lines in the diagram represent data flows, and the box in the middle represents our Amazon Redshift database, which could equally be Google BigQuery or Snowflake as well. Exactly the same principles apply. The idea is that you extract data from various sources that are highlighted in the top left, and you load them into your target database. That's basically the E and the L part of ELT. And notice that there's no effort in terms of trying to perform any calculations, lookups, or aggregations. We could do that if we would like to, but in the ELT model, we try and avoid that at this particular stage. Now, having loaded your data into your database, usually loaded into what we call a staging area. This could just be, in database terms, just a separate schema, a staging schema, if you'd like to call, where it's pretty much the raw data, and it's ready for you to do something downstream. So it's within the database that we'll be doing the final stage, which is T, that is transforming the data. Now you can see in the diagram, I've represented the transformation stage going into the star schema, and that's very typical as well over here. And this is, again, we'll just be using, we pretty much use SQL to do everything, use SQL for calculations, use SQL joins to perform lookups, aggregations, and some, we'll basically down the line when I demonstrate some jobs, we'll also be seeing how we would perform some interesting analytic type functions, all using SQL and within your target database. Once you've pushed your data, then you may give access to your star schema to your reporting team to use for their building their reports, or you can perform perhaps create the normalized structures ready for more sophisticated analytics downstream of this. Now moving on to the next slide, I hope you can see the change. Again, it's almost identical to the previous one, but it has one change, which is in addition to the middle tier of data structures, and there are just relational structures within your database. And the only change here is that the steps from staging to star schema now goes over 2 stages. And this is known as 3-tier or Inman model, as it was first defined by Bill Inman in the 1980s. The previous slide, as I mentioned previously, is referred to as the 2-tier model, and it's something also referred to as the Kimball style architecture, as popularized by Ralph Kimball. Now, the advantage of this model is that if you're finding yourself having to do complicated transformations on your input data, there's apply sophisticated business rules. You may only need to do that once. In the first arrow, going from staging to third normal form, and once you've done that transform, you can then use that transformed data over and over again across multiple star schemas. Having that 3-tier basically helps solve a lot of consistency problems as you go along and your data warehouse expands. What we'll be doing now is shift over to Matillion and show you these concepts in action. Right. Okay. I hope you're all able to see my screen right now. I'm in Matillion ETL for Redshift. And as the name suggests, it will be using Amazon Redshift as the target database. However, the same principles will apply if I was to choose Snowflake or Google BigQuery. To the left, you see Explorer, which basically lists the various jobs that are available. I'll be walking you through some of these jobs to show you how these work, as well as point out some of the common techniques used in ELT. And one thing you may notice is that there are two types of jobs that are available in Matillion. There are orchestration jobs and transformation jobs. Orchestration jobs help us with the E and L part, that is extract data from source and load it into staging tables. The other job type, which is transformation jobs, help us with the T part, that is transform data. Please note that the transformation jobs work within the context of the target database. So all required data must already be in the database prior to launching your transformation jobs. So the first job we'll be looking into is something that is very common, or almost everyone has it, which is basically to build a data dimension. Almost every data warehouse will have at least one of these, or some means by which you will build this data dimension. So on screen, we have a very simple, straightforward job. All it's doing is it's creating a table using a create table component. As you can see, we just provide you with a very simple interface to put in the necessary information, and we basically derive the appropriate SQL based on your inputs. Once that's done, we then launch a transformation job to help populate this table. Now, you may have a schedule or something like that, which just runs this on a daily basis. So going into the transformation job itself, as you can see, it's got a different layout and look to it. One of the first components we have here is sequence generator. Again, this is something which you might have come across day in, day out when you're using other tools. In this case, we are basically generating a sequence or a number for a given number set of days which we'd like to derive this date dimension. We then follow it up with a calculator component. In Matillion, you would use calculator components to add new columns where you're basically performing calculations on data that's available to you. So if I just go into the calculations part, you can see I'm just, here's the sequence that's generated using my generator previously. And then I'm deriving a new column, d_date. And the expression to the right is basically a SQL expression. In this case, because we're on Redshift, you can use any expression that's valid in Redshift, or you can use any of the functions that are valid on the specific platform. So what you see here is a very straightforward expression. We basically choose a base date, static base date in this case, and we're adding the sequence to it, and hence deriving an increasing date as we go by. If I simply switch to the sample tab and click on data, you should be able to see the dates that we generate. They are in an increasing order as they go along. Then moving on from there, we have another calculator component. In this case, we're now using the date we've generated previously to derive additional data that we need in this particular table. You may all be pretty much familiar with the various attributes that are part of your data dimension. So here I have a few, but you may add as many as you like as you go along. Again, each of these are using basic Redshift functions to derive the appropriate value. You can use any other SQL function that you think is necessary in your use case. Moving on from there, then we're again with a calculator component. In this case, we're actually deriving some relative values. So again, this is very common across data warehouses for where you might want to perform some year-on-year analysis, this week, last week, or something like that. So you do need flags in your data dimension to identify what's today, what's yesterday, what's last week, what's last year, and so on. So this component here just gives me the ability to add those attributes. Again, if you notice, all I'm doing is referring to columns that are already in my data set, which are all from my previous component, and then I'm deriving additional value from that as such. And finally, I'm writing this data that I've derived into a target table, dim date. I've chosen a table output component, which has chosen and also chosen a truncate strategy. So it's simply going to truncate and load this particular table whenever we're going to run this job. Just coming back to our orchestration job here, you might want to schedule it to run on a daily basis. We do have a built-in scheduler, which is based on quads, and you can basically attach any sort of schedule you like and decide on the frequency you'd like to go with. Okay, that's a bit on the data dimension, just showing you how to perform calculations. We've seen how we are using just simple SQL expressions to perform your calculations and then derive additional columns and then write to a target. There's this next job, which is just like something to help me identify what's really happened in the background. This is not a job that I would run. This is just for monitoring what's happened and the type of metadata that's being held in my database. For example, here's the dim date table that was generated by my previous job. And I'm actually using a table input component to identify the table as such. If I go to sample, I can basically, good, that's right. Yes, I do need to run this job to populate that data. As you can see, it's basically inserting data at that point, and that's done about 15,000 rows. Okay, let's get back and check what's happening here. So if I go back to sample, yep, we got 15,000 rows, and here we can see the actual data that's in that particular table as such. And if I need to find out more, I can always scroll to the right and see more of the data as to what's derived at that point. Anyway, the bit I wanted to show you was also the aggregate, which is simply attached to it. The aggregate component basically lets you perform some aggregate functions. It just gives you an easy interface to quickly build the necessary SQL instead of you having to do that by yourself. So if I click on data, it basically brings back the max and the min date, and this is something that you might just want to take a look at, because all this means is whenever you marry up the data dimension with any other data that's coming in, anything that falls outside the min date, you may be missing out on it. So you may be able to or you may be required to handle that in a specific case. And in a similar way, you could actually use the same to actually check out what all is in your other tables as you go along. Right. The other job we'll move on to is this one, import flights data. We commonly use this civil aviation data set when in most of our demos. You may have all seen these demos as such. It's a really large table, I mean, if I must say so. It's got about 123 million rows in it. This pattern here is just to show you the ELT approach in terms of loading data as such. So we start off by creating a target table into which we'll be loading this data. The distribution style, if you notice on this component, is currently set to even. Now, this is a deliberate strategy here because of the type of data I'm trying to load in. The data is also sitting in files in S3. It's literally from 1980, 81, 82 till about 2010, I think. And it's one file per year. So setting this distribution style would basically help me quickly load that data in parallel, making use of all available nodes in that Redshift cluster. And the S3 load component itself, as you can see, it does support loading it using prefixes, and which means this component would load any files beginning with 19. It would be until 1999, and the other component would load anything after year 2000 as such. Once this data is loaded, so basically this here itself is basically extract and load. We're loading this data into the raw flights table. We then use a transformation job to perform some operations on this data and then write this into another stage table. One of the first things we're doing here is basically trimming the flight number. The reason behind this is if you look at the final table where these rows will be written, it's called raw flights. And you may notice the distribution style here, unlike my raw flights, is basically key-based distribution, and it's distributing it on flight number. So before I'm writing this data into the stage flights table, I'm actually preparing it by applying some cleansing rules, if you may call it. So the first one's basically trimming it and making sure it conforms to the target field size that we expect it to be. Then we basically remove any flights which have null or blank data in the flight number column. If that's going to be the primary key or the key column, then obviously having null or blank doesn't really make sense. Then we use the rename column to basically make sure we have the appropriate names available that's suitable for your target structure as such. And finally, I'm using a rewrite table component here. Usually in production, this may not be a good idea purely because rewrite table tends to drop and recreate a table. So like me, if you are actually basically writing incoming data to another staging table, it's fine to use rewrite table because you may tend to further process this data before you push it into your facts or dimensions. But basically this component drops and recreates that table, so it might not be a good idea if you simply were to point it at a fact or dimension table that you already have. So then again, this job here, all it's doing is cleaning up my incoming data, performing calculations and removing unwanted rows and writing it into stage flights. And then I run analyze tables component on these tables. This is to make sure Redshift has updated statistics and whatever else it needs to derive in order to help me quickly process data as I go along into further jobs where I'm going to do more processing as such. Right, so that's the import flight data. So now let's move on to another transformation job. In this case, this is basically a job where we're then moving it or moving data from my staging table, which is stage flights, to a table in third normal form, as we've seen in our second slide with the Inman model. Of course, the end result of this could just be your fact and or dimension if you were to deal with the Kimball style, but we'll just go through what we're doing here. So as in all the previous instances, we start off with a table input component where you're basically pointing at the source table where you like to get started. We then use a calculator component. Please note we're still trying to work out how you work with calculations in the context of ELT. And if you look into the detail here, it's fairly straightforward. I've mentioned already that we are going to use SQL that's compatible with your target database, help you quickly come up with the appropriate calculations. So as you can see, I'm just calculating the flight date column based on the values that we derive from our staging table. There are various attributes I'm deriving here, a flight date, which is a date based on the year, day of month, and month that's available. Then we have the origin, which basically we're making sure it conforms to the three character width that we are going to set in the target. The same goes with destination, and then we are calculating flight departure time based on the departure time that's available in our data set. Now, this is again a common situation that sometimes you may have null values in a certain field, and there may be another column available in your row which you could use to replace this null value with. A typical strategy would be to use something like the coalesce function to replace the null value with the appropriate value from the other column, or you may have a catch-all that will basically be populated if both columns would have null in them. So this is just to show you how you could do that within Matillion. And in a similar sense, we are then converting the arrival delay and departure delay into numeric columns. As we'll see down the line, we'll be performing further analysis using that data as such. So let me just click cancel from here. The next column, or the next one is fairly straightforward. We are just renaming some of the columns to, again, like in this case, you would notice arrival delay calc and departure delay calculated columns are being renamed to arrival delay and departure delay. And all they would do is they'll simply replace the any other columns by that name in the incoming data. Then we are checking for duplicates. It's quite possible, and this is a common scenario across these systems, you would see that you may have duplicates in your data. And Now here, I'm not really interested in getting rid of duplicates. All I'd like to do is associate something like a row number. For example, if I have 2 rows, I would want to associate number 1 with the first row and number 2 with the second row, based on some window calculation functions. So in this case, this is basically an example of that, wherein I'm just executing the row number function, and we are partitioning it by various fields. Again, how you partition depends on individual use case. You need to be able to tell Matillion as to how exactly they're able to say that this row is a duplicate. And again, this is nothing special to Matillion itself. You're basically using a window function from Redshift. The row number function from Redshift to help you come up with these values as such. And then finally, I'm just writing this data to norm flights. And just to summarize what we've done, we basically converted the data types in certain instances. We made sure some of the other columns conform to the data types that we'll be using later on. Then we've also added some metadata where we're deriving something like a rank on to identify duplicates. And then finally, we are pushing that into a target table, which I've called norm flights. And as you can see, it's set to key distribution, and it's going to be distributed on the flight num column that we've derived in this particular workflow. Again, just to reiterate, all we're doing here is using SQL at each and every step to help you come up with the appropriate way in which you can handle this data. Moving on from calculations, we've got another job where we're trying to perform some lookups. So here, I'm basically utilizing my norm flight table with the dim date table that we created previously. And basically, I'm joining these two using the join component. And this is something we've talked about previously. That is, we were basically using these operations, these components in Matillion. For example, the join component here, it's an interface to help you perform a quick SQL join, if you like. So as you can see, we are basically performing a left join instead of an inner, so that we don't lose any data if our date range for that data falls outside what we're looking for. And then we define some output columns as to what we would like from join. We've chosen the columns we need from flights, and we've then chosen what we'd like from the dim date table. One great thing here is because it's ELT, all of this is going to happen on your database, which in this case is Redshift. And we're simply making use of the capabilities of the platform to perform these operations. And then we, in this component here, we're just catching those rows where we couldn't find a match for a date key, and we're just setting it to -1. So we're able to identify possibly the rows which couldn't make through the join. And then we have the next section, which basically tries to create or write the relevant data out to our fact flight table. The first component here is basically removing duplicates. If you remember, in our calculations job, we basically derived something like a rank on duplicates. So here we are making sure that we exclude those duplicates by simply selecting rows where the duplicate sequence is 1. Anything other than 1, it's just a duplicate. We don't really need that in our target as such. And then we just do the same. We just rename some of the columns based on what we think is suitable for the target. And then we just write that into the fact flights table. That was just a simple lookup. I hope that was fairly straightforward. And then moving on to aggregations. Again, here you can see the same fact flights table being utilized to actually derive 2 aggregates with different granularity. The replicate component helps us multiplex your input. Of course, with the latest version, you no longer need this component. Every input automatically supports deriving multiple branches from it. So you don't really need this component going forward. So, yeah, what we see here is your fact flights. And in the first branch, we're basically trying to derive or calculate the average delay by arrival airport. If I select my aggregate component, the one I'm using here, you can see I'm grouping it by destination, which is the airport where it's landed. And then I'm basically calculating the average of the arrival delay field. Not sure if you remember, but we did perform some calculations on the arrival delay earlier, where we converted it from a bar chart to a numeric field to help us with this calculation over here. Once we derive the aggregate, we're simply writing the data to the output table. The second workflow is a bit more involved. The reason for this is we're trying to do average delay by arrival airport and year. And in this case, what we find is, in a given year, you may have multiple records in which where the distance calculated may not always be the same. It might just be off by a few meters most of the time. You may have one journey which may have recorded something as 900 miles, another one which are recorded as 895 miles or 98 miles, and so on. And the first part of this is basically trying to arrive or cleanse some of the data that we have, wherein by mistake it's possible that sometimes the distance is just returned as null. In those instances, we basically would like to identify the most appropriate distance based on the most common distance that's recorded between the rows, and then use that to populate the null values. So these calculations are basically just an effort to help us do that. So the first thing is we're basically deriving the flight year, and then we move on to perform some aggregations where we are first grouping it by the destination, which is the airport, and the flight year, and we're calculating an average on the arrival delay. Now, this is the bit where we're basically using the lead or lag functions to basically derive the appropriate value. As you can see, there's a specific component to do that, and all you're doing is basically filling in the necessary data to identify the partition, and then identify the ordering that you'd like based on the other columns that should participate in this aggregate as such. Following on, we're just calculating some year-on-year values, and then we use rank component to, maybe just rank these in a certain order. So you might say, oh, this is the airport where we've basically had some improvement in terms of delays, so fewer delays compared to what it was previous year or something like that, and then write that into a target table.
Great. Thanks for that, Kalyan. Thanks for that great demo there. So we do have some questions that are lined up for you. Obviously, if anyone's got any further questions, now we're in the Q&A section of the call. Do drop them into the Q&A panel, and then we can put those to Kalyan or one of our other team who are on the line, and we can hopefully give you a response for those. Just before we move on to the Q&A section, hopefully the demonstration today was really useful for you all. I just wanted to point out that the demonstration today was based around using Matillion ETL for Redshift, and therefore based around the Redshift data warehouse platform. But Matillion does have two other platforms, one for Google BigQuery and one for Snowflake. So as a tool, if you're using any of those three cloud data warehouses, be it Redshift, Google BigQuery or Snowflake, you can use Matillion in the fashion that we've shown you today. So you can leverage it for that ELT architecture and obviously get some of the benefits from that, as each of the platforms work in exactly the same way, and you'll get the functionality across all of those three data warehouse platforms. So hopefully it was a good initial look at what Matillion can provide. And of course, if you do want to discuss any of the ELT techniques that you can develop using Matillion, or find out a bit more about how you can, of course, test these out for yourself via a free trial, do get in touch with us and we'd be pleased to help you out with that. But what we want to do at this point is obviously move on to the Q&A, as we've got some good questions lined up. So I'm just going to put the first one over to you then, Kalyan. So we had a really good question here come in earlier about when should a company choose ELT over ETL, if you can provide a kind of succinct response to that.
Sure. I think it's I would say it's based on one thing to be based on your the target platform that you choose. With most of the MPP platforms, traditional ETL models where which tend to basically run most of the processing on your ETL server, and maybe fire inserts and updates at a certain interval or a certain rate at your target database. Now, this sort of workflow doesn't always suit the target platforms. Again, this depends on the number of rows you're working with. If it's just a couple of hundred rows, yes, it should be fine with, or even 1,000 rows or something like that. But any more than that, MPP platforms like Redshift or Google BigQuery and so on, they're not really built for row-level table updates at that pace. So I think that would be a good point or a place where you would choose your target platform. I mean, even otherwise, if you're dealing with really large data sets, one of the points I made earlier was these platforms are built to actually quickly, process your data, go through it and do various things. So if there's a lot of data munging that needs to be done, then these platforms are great at it. And tools like Matillion just let you quickly latch onto them and make use of their power to help you do that. I hope that gave you some direction.
Great, thanks for that, Kalyan. So another question here asking, can you trigger a Matillion job using a REST API?
Good. Yes, we can. So we do have a REST API, and yes, it's possible you could use the external tools, and as long as the Matillion server is visible from your scheduler or whatever system you're triggering it from, you should be able to launch jobs in Matillion.
Fantastic. And then we've got Pravin here asking, what's the best practice for creating history? And usually is that done within Matillion? Right,
good question. So Matillion itself is just, how would I put it? Should I say data agnostic? It doesn't really understand or know your data. So when you say history, well, I would say you're probably interested in holding all relevant data in the target platform. Then yes, you can easily use Matillion to push that data into Redshift. And as you've seen, we provide you with various components to help you with that process. So it could just be a case of appending data to an existing table, could be a case of just maintaining partitions and stuff like that. So it depends on your use case. But Matillion itself, as a tool, is not really aware of history. You just implement the necessary workflows in the product as such. I hope that helps.
Great, thanks for that, Kalyan. So another quick question here from Shilpa about how do you enforce referential integrity inside the SAR schema?
Good question. Well, I think enforcing is not something. If you're talking just in the context of Redshift and things of that nature. Enforcing a constraint, a foreign key constraint, is not something these platforms are good at. They simply ignore it. So all that you can do is, in one of our examples, we basically did that for dates. Wherein we said we only have a date range which applies from 1990 till I think 2023, and basically, whenever you're performing a join of sorts for lookups and all, go with left outer join, and then you use calculator component to identify null values in the reference column, and then map it to certain values, or even there are various other components that might probably be able to help you identify your data. There's an accept component, there's the intersect component, which you might use to identify certain rows which do not conform to these workflows. You identify them probably, it depends on what you want to do with those rows, whether you want to map a dummy value to it or take further action. That's up to you. But in Matillion, you would use one of the join components to be able to do that.
Excellent. Thanks for that, Kalyan. Yeah, great questions coming through here, everyone. So do keep them coming if you have any more, no matter how big or small. So the next one, Pravin, is just wondering, how would you load data from RDMS to Redshift using Matillion?
Right, yes. So RDBMS, you would use something like a database query component to work with your relational databases. We also have RDS query component if your database is hosted in Amazon RDS service. And as you can see from the properties, it's fairly typical of any service which deals with database connections. The top half deals with your source system. In this case, we've got SQL Server, but we do configure it with others as well. Now, if your database is not listed in this case, don't worry. As long as you've got a JDBC Type 4 driver for your database, you can upload that driver into Matillion and use this component to connect your database and pull data into Redshift or Google BigQuery or Snowflake. And as you can see here again, the bottom half of the properties deal with your target table. So as discussed earlier, the orchestration jobs basically do your extract and load. So all data extracted from your source RDBMS is basically staged in S3 and then pushed into the appropriate table that you define here in your Redshift cluster. I hope that's clear.
Fantastic. Yeah, thanks for that short answer on that Kelly, and that's hopefully cleared that up. So thanks very much, everyone, for your questions. I know we're slightly over the hour now, so I think what we'll do is wrap up here. There are a couple of questions we didn't manage to get round to, so obviously we'll reach out to you directly with a response to that. But if you do have any questions that arise after we've ended the session, of course, you can always reach out to Matillion at any time. Contact details are on our website, and we'd be pleased to help you out with any questions. Or, of course, you can always forward them to our support team as well via support@matillion.com. So thanks very much, everyone, for joining. I hope it was a useful session today to learn a bit more about the capabilities of using an ELT approach. If you do want to have a closer look at Matillion, learn a bit more about the functionality, how you can use things like Redshift Spectrum inside Matillion and push data out to other platforms as well once you've transformed it, then we do offer free training sessions, free 1-hour training sessions, or live demonstrations via our website. So do go on there, and you'll be able to navigate your way to one of our free demo sessions. But in the meantime, thanks very much for joining. Enjoy the rest of your day or evening, and we hope to see you very soon again on one of our webinars. So thanks very much, everyone, and goodbye.